Isn't that where you're like hooked up to stuff? No, I have, but I thought that they were like using them for fuel or something. I don't know. Maybe I feel like I don't know. We need extra time. Let's do it after the news. Okay. Because it's like, do they know they're in the matrix? So it's like maybe just live a happy life, you know? I don't know. I probably wouldn't. I don't know. I feel like if there was like a zombie apocalypse, I'd just like go outside. I'm not like a survivor, but I wouldn't be like, you know, out there trying to escape. I just feel like, I'm a zombie. All right. So I didn't grade all your tests. All your part ones are graded, but I'm still working on the free response part 2. So I'll put them in focus during 7th is my off period today. I'll type them in. You will have the chance to do test corrections, but I can't let you do test corrections till everyone has taken the test, and I'm still trying to catch a couple of people that need to take it. So it'll start next week for test corrections, okay? And then if you do not have a 7th or an 8th period, neither do I, but you have to talk to me about it because I can't do every 7th and 8th. I have meetings and stuff like that. So if you want to do it during then, you can. Otherwise, Monday and Thursday are my tutorings after school. Okay? All right. So before we go on to your notes today, I have a little plug for Mu Alpha Theta. You can join it. Here it is. You've taken enough math classes, or you couldn't be in calculus. Okay, but you have to have at least an 85. This is last year's class. And then at Burke, we would say 80 because of the quality points, but I don't know if y'all do that. Do y'all know if you did it? You don't know? Okay, if you want to know, you can email Miss Dodgen or ask her after class. But it looks great on a resume if you're, or in a college application. So if that's something you're thinking about, Miss Dodgen is right next door and you can email her if you have any questions. Yes? I can give you time at the end of class, sure. Okay? And then there's the link, and it's also been on the announcements. Okay? All right. So we're gonna now start. We're done mostly with limits. We're gonna go into derivatives. So for my transfer kids, I understand y'all have already maybe learned most of this, but just hang tight, go through it again. Eventually we'll catch up to where you left off. So at the top of your notes, please. Okay, a derivative is the process of finding an equation that will give you the slope for an equation at any x value. Before we get into how to take a derivative, we're going to go over notation. If your function is called f of x, the way that you would denote that you took a derivative is you would put f apostrophe x. And you would say that as f prime of x. Now, because taking a derivative is just like an algorithm, you can take the derivative twice and you would call it the second derivative, or f double prime. Okay, you could also take a third derivative and call it f triple prime. Okay, but it's just an algorithm that I'm going to show you how to do that's not too hard. Okay, if you called the function y, very similarly, you would call the first derivative y prime, the second derivative y double prime, and the third derivative y triple prime. Okay, occasionally, rather than using the prime notation, if your function is called y, you could call it dy dx. That stands for the derivative of y with respect to x. Okay, but I want you to understand that even though this one looks uglier, It's the same as y prime. It's the same as f prime. It's just a different notation. That means take the derivative. Now, if I want to take the derivative again, you're going to make it d squared y dx squared. Okay, and it looks a little bit uglier, but that still means y double prime, take the derivative twice. Okay, so for my third derivative, instead of using squareds, I'll use cubes. So it'll be d cubed y dx cubed. Okay, so now that we know the notation for taking derivatives, let's learn what the power rule is, okay? So if you have a constant, automatically the derivative is going to be 0. Okay, it doesn't matter what the constant is. When you take the derivative of a constant, it automatically goes to 0. If you have a polynomial, meaning like x cubed or x to the 4 or something like that, okay, you're going to take what the exponent is and you're going to times it down to the front. So for example, if it's x to the n, you're going to bring the n down to the front, and then you're going to reduce the power by 1. So instead of x to the n, it's going to be x to the n minus 1. Okay, so let's work 1, 2, and 3. Okay, take a look at number 1. I want the derivative of 10x to the 4. I'm going to times the 4 down on the 10. What's 4 times 10? 40. And then I'm going to reduce the power by 1. So instead of an x4, now it's an x what? 3. Easy? Okay, next one. You took a derivative. Good job. Okay, number 2. I have 6x cubed. D dx means take the derivative. So I'm going to do 3 times 6. What's that? Then I'm going to reduce the power by 1. So instead of x cubed, now it's x squared. Very good. Okay, last one. I want the derivative of 5. What type of equation is 5? Is it a power or a constant? 5 is a constant. What's the derivative of any constant? 0. Very good. Okay, now if you have a string of terms that are added or subtracted, okay, you're basically just going to take the derivative on each one. So this would be the derivative of f. We're going to call that f prime. And then you would take the derivative of the next term, which would be g prime. Okay, and if you had more than 2 terms, you just apply the derivative to everybody. So now let's take a look at number 4. Okay, I have 3x4 plus 7x squared plus 2x plus 6. Okay, it's got 4 terms. I'm going to do the derivative on each one. Let's start with the 3x to the 4. Times the 4 down. What's my new number in the front? X to the what? 3, because I'm going to power it down 1 number. Okay, next one, I have 2 times 7 is 14. Power it down 1 level. Now my x squared is just a regular x. Now, when you get to 2x, there's not an exponent on it. That means it's an x to the 1. So 1 times 2 is 2. And then x is going to go from an x1 to an x what? 0. Now, if it's an x to the 0, what does that mean it's the same as? Anything to the 0 is 1, which means really this is a 2 times 1. Really, it's just a 2. Okay, so for the future, I'm not going to write any more x to the 0s. Okay, last term is a plus 6. What type of number is that? Constant. What's the derivative of constant? 0. So I'm going to rewrite this as 12x3 plus 14x plus 2. Okay, now notice that that's called dy dx because I took the derivative once. Where the hole punch hit is d squared y dx squared, which is the derivative twice. So I'm just going to do it one more time. Look at your equation. I have a 12x cubed. What is 3 times 12? 36. And then my x drops down to what power? Squared. Very good. Plus 14x is an x to the 1. So what's 1 times 14? And then what happens to my x? It drops down to a x to the 0, which means really we're not going to put it. Okay, what about my plus 2? Okay, it's going to go to 0 because it's what type of number? Constant, very good. Okay, take a look at the next one. 8x5 plus 8x3 plus 7x minus 4. Here we go. First term, what's the derivative going to be? Okay, 5 times 8 is 40. X drops down to the 4th power. Very good. Okay, next one, 3 times 8. 24. And then my x cubed is now a x what? Squared. My 7x is going to turn into just a what? 7. Because I do 1 times 7, and then x drops to the 0 and it goes away. What about my minus 4? 0, because it's what type of number? Constant. Very good. Okay, go ahead and take your second derivative. Okay, remember, we're going to call it d squared y dx squared. So you're timesing the exponent down, reduce the power by 1, repeat through all 3 terms. Okay, once you have it, look up, check and see if you got it right. Okay, 4 times 40 is 1/60 x to the 3. That'd be 48x. 7 drops off because it was a constant. Good? Turn the page. So now let's talk about what on earth are we doing? Okay, when you take the derivative, okay, we talked about at the top of your notes, you're creating a slope generator that is going to give you the slope at any x value. So for number 1, or actually, I don't know how this is number 6, but it's number 6. Okay, take the derivative and write it right here next to f prime. So f prime of x equals, what would the first term be? Okay, 6x squared, and then what? Minus 6. Where does the x go? Now it's an x to the 0, which means we don't put it, right? Okay, this formula will give you the slope of the graph at any x that you want. At any x value that you want. So if I find f prime of 0, I plug in 0, and the answer that comes out is going to be how steep the graph is at that point. Let's do it. I want f prime of 0. Then that would be 6 times 0 squared minus 6. But what's 0 squared? Times 6 is still 0. And what is 0 take away 6? Negative 6. Now, I want you to look on your graph. This is a graph of 2x cubed minus 6x. Go to 0, that'd be right here. That's exactly how steep the graph is at that point. Your slope, I'm going to use m for slope, is negative 6. Okay? Now let's do it at 1. Ready? I want f prime of 1. Then I'm going to take the x value, plug it into my equation for slope, and the number that comes out is exactly how steep the graph is at that point. So I'm going to have 6 times 1 squared minus 6. But what's 1 squared? 1. 1 times 6 is 6, and 6 take away 6 is 0. Okay, find 1 on your graph. Okay, if this is 2, then 1 would be right here. And do you notice that at this point in the graph, it kind of bottoms out, right? So your slope at that point would be perfectly flat. Okay, so I'm downhill here, but as I hit that bottom out point, I'd be perfectly flat, which is consistent with the 0 slope. Okay, let's now do negative 1. Instead of a positive 1, we'll plug in a negative 1. 6 times negative 1 squared minus 6. But what is -1 if I square it? Still +1, right? And then I times it by 6, I still get 6, and then 6 minus 6 is still 0. So now go on your graph at -1 and see if you still have a 0 slope. Okay, -1 would be right here. And instead of me bottoming out to 0, okay, this is just a peak with a flat spot. Okay, so at -1, I see that I have another flat slope. Okay, we're gonna call that, okay, any 0 slope, we're gonna call an HT. Okay, that stands for horizontal tangent. Okay. And a horizontal tangent is just where your graph kind of flattens out and gives you a perfectly flat, either a bottom or a top. Okay. Last one we're going to plug in is 2. So I want f prime of 2. That'd be 6 times 2 squared minus 6. What is 2 squared? 4. What is 4 times 6? 24 minus 6 gives me 18. Okay, then I want you to come over here to your graph. When your x is 2, that would be right here. And the steepness of that graph would be 18. Okay, now notice it's positive because that piece of the graph is like super steep, right? Okay, and it's uphill, that would be your slope of 18. So notice that an uphill slope came out positive, a negative slope came out downhill, and then your zeros are going to come out flat. Okay, so using that information, I don't want to do all of the next question. I just want you to look at the graph and tell me if it'll come out positive, negative, or 0. Okay, take a look at number 7. Okay, your graph is over here to the side. I want you to find f prime of 0. So go to 0 on the graph, put your pencil on it. And then I want you to tell me if it would come out to be positive, negative, or 0. Ready? 1, 2, 3. 0 is correct. Because at 0, my graph is perfectly flat. So just put equals 0. Okay, next one, I want f prime of 1. So find 1 on the graph. And then you're going to answer positive, negative, or 0. Ready? 1, 2, 3. Negative is correct. Because at 1, I can see that I have a downhill tilt. That's a negative slope. Okay, then next one, I want f prime of 3. Find 3 on your graph. Answer positive, negative, or 0. Ready? 1, 2, 3. 0. This is 3 right here. It's another flat spot. Okay? You get the idea? Okay. Go ahead and turn the page. Now, obviously, every equation you encounter isn't going to be a nice, easy polynomial. So we're going to look at some other problem types, and then I'm going to give you some time to start on your delta math. So if you'll turn the page, please look at number 8. Okay, you have a polynomial all divided by 2x. What I want you to do is rewrite. You're good. You just leave it there. Okay, we're going to rewrite that equation. We need it to be written as powers, okay, not as like one big fraction. So if all of this is divided by 2x, then I'm just going to divide each one by 2x separately. So I'm going to rewrite f of x equals as 6x4 divided by 2x plus 8x3 divided by 2x. And then minus 12 divided by 2x. Okay, so I'm going to simplify this because I can't use power rule if it's a big, huge fraction. Okay, now you learned how to reduce this back in probably algebra 2. Okay, what's 6 divided by 2 for the first term? Okay, that's going to be a 3. And then what happens if I had an x4, but I divide by an x? Now it's only x3 because you should subtract your exponents. So it's 3x cubed plus. Next term, what's 8 divided by 2 in the front? 4. And then I had an x cubed, but I divided an x out, so now it's x squared. Okay, next term, I had a minus 12 divided by 2. Minus 6. But then here's the problem. My only x that's left is on the bottom. Anytime your x is left on the bottom, you're going to use a negative exponent to pull it from the bottom to the top. So this is going to be x to the negative 1. Okay, so I'm going to put a little star here, use negative exponents for variables on bottom. Okay, because again, I can't do power rule if my x is on the bottom. I have to bring it to the top, so I'll use a negative to fix that. From here, you're taking the derivative the same way we did it before. So for my 3x cubed, what will the derivative of that be? Okay, 9x squared plus 2 times 4, what's that? 8x to the what? 1 now, so I'm not going to put a 1, but we know it's there. Okay, for my last term, what's negative 1 times negative 6? Plus 6, and my x, if I take away 1 more, is going to be what power? Negative 2, very good. Okay, now, one thing I want you to be a lot more careful about as we're planning for the AP test, even though it feels far away, is labeling stuff. So this would not be good for the AP test. If nothing's labeled, they're not going to grade it. So if this was F, this is also F. But what happened from here to here? I took a what? A derivative, so I need to put a prime on there. That's right. So this is now F prime. Now, one other thing I want you to do is your homework says you can't use negative exponents. So if I have a negative exponent, all that means is I'm going to push that x squared back into the bottom of the fraction. So here's going to be your final answer. 9x squared plus 8x plus 6 over x squared. And you're just going to take that squared term and put it back on the bottom. Okay, now let's go back and read the question. Here's what it actually said. It said to find the slope of the function at -1. Now this tells me the slope at any x that I want. Where do I want the slope? At what x? -1, so I'm just going to plug it in, okay? So we're going to do f prime equals, with a -1 plugged in, I'm going to have 9 times -1 squared plus 8 times -1 plus 6 over -1 squared. And I'm literally just taking that -1 and I'm popping it into all of the spots where I had x's. -1, if you square it, is going to turn into a what? Regular 1 times 9 is 9. Okay, then my next term, I have a -1 times 8. That's going to turn that into a -8. And then for my last term here, -1 squared is a +1. Divide it with the 6, that's going to stay a +6. So 9 minus 8 is 1 plus 6 more, the slope is 7. Now, quick question. If my slope came out to be a +7, would I say that my f function is increasing, decreasing, or horizontal? Okay, because it came out to be a +7, I would say therefore f is increasing. Okay, if your slope is positive or uphill, okay, then that's what increasing means. Okay, let's take a look at number 9. Number 9, I see I have some x's in the bottom. Now we know what to do with them. If x is on the bottom, what are we going to do with the exponent? Okay, so rewrite your next question. Okay, using negative exponents for any of the x's on the bottom. Okay, so I'm going to put RW for rewrite. This is f of x equals. Okay, and then for the first one, can I put 2x to the -4? Probably some of you put it. Okay, but you can't. Here's why. You can only bring the x up. That's not a 2. What number is that? A 1/2. So this is a 1/2. And then the x can come up with a negative exponent. 2 cannot. Okay, for my next term, I have a 6x to the minus 3. Then a minus 5x and a plus 9. Okay, also notice that I've labeled my work that this is f, so is this. I haven't actually taken the derivative yet. I'm just getting it into power form so that I can use the power rule. Okay, go ahead and take your derivative. We'll go one term at a time, calling it f prime. No, I just forgot to write. Plus x to the 3. Okay, sorry. Okay, for my first term, I'm going to take my -4 and I'm going to times it down on the half. What's half of -4? -2. Then I'm going to minus one more from an already -4. What's my new power? -5. Very good. Next term, I have -3 times by 6. What's that? -18. What's the new power when I go down from -3? -4. Okay, I'm going to let this one cut back in line. What's the derivative of x cubed? Okay, no tricks there, 3x squared. Then for my minus 5x, that's a 5x to the 1. What's that going to go to? 1 times -5 is -5. X drops down to a 0 power, which means we don't put it. What about the plus 9 here, which is a constant? Goes to 0, very good. Okay, now this is correct, but your homework says no negative exponents. So I'm going to put f prime equals -2 over x5 minus 18 over x4. And I'm going to push those negative exponents back down into the denominator. Does that make sense? Okay. Now, to evaluate our slope, I'm going to be a little bit lazy here, and I'm just going to go straight to this step instead of showing the -1 plugged in. So put f prime of -1, and then we're just going to go one term at a time, but we're going to kind of mental math it. So if I take a -1 and I raise it to the 5th power, how is this part going to come out? On the bottom. It's going to stay negative, but then I'm going to divide it with what? -2, it's going to come out to be a +2. Okay, next term, I have a -1, and I'm raising it to the 4th power. Positive or negative? Positive, but then I'm going to divide it with the what? -18, it's going to come out to be -18. My next term is a +3. I'm going to put a -1 squared next to it. What's -1 squared going to be? Positive, times it by my 3, it's going to stay positive. And then I have a -5. Now, without even figuring out what the number is it going to come out plus or minus? Okay, the minus pieces are a lot bigger, right? So we know this is going to come out to be negative. Then, can I conclude that f is increasing, decreasing, or horizontal? Decreasing, very good. So I'm going to put therefore f is decreasing. Okay, because my slope, when I plugged in that value, it came out to be a negative. If it had come out to be a 0, that's when you would say it's horizontal. Okay, are we all good with that? Okay, so other than exponents from the bottom turning negative, you also have to know how to do this with square roots. So if you'll take a look at number 10, does anyone remember from pre-cal or algebra 2, what is a square root of x the same as in a power form? To the power of 1/2, very good. Okay, a square root and a 1/2 power are the same. Similarly, a cubic root is the same as what power? Do we remember? 1/3, very good. Okay, now, if you have a different kind of power, okay, you're just gonna fraction it with that number. Now, let's say that you have a power and a root. So for example, right here, do you see I have a square root of x, but then it also has a 7th on it? Okay, for that, if you have an nth root of x to the n, you're gonna put the power on top and the root on bottom. power gets to be the top of the fraction, and then the type of root is going to go onto the bottom. So now let's take number 10 and let's switch it to be in power form instead of the radical form. So I'm going to rewrite RW, y equals 8 times the square root of x to the 7. What is a square root the same as a power? The half, right? So then I'm going to cut 7 in half and make it 7/2. Okay, but the power goes on top, and then the square root is a 2 goes on the bottom. Okay, do the next one. It'll be -4 in the front. My x is to the power of 5, and then over 2 for the square root. My last one there is just a +6 square root x. And a square root x by itself is what power? 1/2. Very good. All right, now that's why I haven't taken the derivative yet, but I've prepped it for me to take the derivative. What do we call the derivative when we go from y to the first derivative? Okay, y prime or dy dx. Okay, and I'm going to write both because your homework, it'll ask you sometimes to find y prime, sometimes it'll call it dy dx, but it's the same thing. Okay, first thing we're going to do is do 7/2 times 8. Okay, and I'm just going to write it like that for now because part of your AP test and a lot of my tests will have a calculator and a non-calculator. So I want to make sure you know how to do that, which we'll do in a second. Okay, then my x was to the 7/2, but I need to take away 1. So I times the 7/2 down to the front, and then I'm going to take away 1. Let's review how to do that. Okay, when you are multiplying a fraction by a number, put the number over 1, times the tops together, times the bottoms together, and then divide. What is 8 times 7? Okay, and 1 times 2 is 2. What is 56 divided by 2? 28 is correct. Now, let's say that you don't like that. Okay, that's fine. I'll give you another method. If you have an 8 on top, you can divide it with the 2 first. What's 8 divided by 2? 4. And what's 4 times the 7? Still 28. So if you want to do the divided by first and it divides cleanly, that's fine. So 8 divided by 2 is 4, times by the 7, I still get 28. Now let's do this -1. When you take away 1 as a fraction, I want you to use 1 whole instead of 1. So what I mean by that is I'm going to make this 2/2. So now 2 divided by 2 is still 1, but 7/2 take away 2/2 is how many? 5/2. So when you subtract your 1 to power the exponent down, just make it a 2/2, and then it can subtract easy. Okay, next term, we have minus. I had a 4 already in the front. I'm going to times it by 5/2. And then my x to the 5/2 is going to have to minus 1. Let's do the number in the front first. What's 4 times 5? Divided by 2? To 10. Okay, if you hate that, that's no problem. Do the 4 divided by 2 first. That gives you 2. Times it by the 5, you're still going to get 10. Okay, now let's subtract the exponent. Taking away 1, I'm going to change that to a 2/2. What is 5/2 take away 2/2? 3/2. Okay, last term. I had a 6x to the half. What is half of 6? 3. And then my x to the 1/2 is going to have to take away 2/2. What is 1/2 take away 2/2? 1 take away 2 would be -1/2, yeah? All right, so it should look like that. Okay, then your homework said no negative exponents. Okay, it also asks you to put it back into square root form. So let's do that for our final answer. Y prime equals, my 28 still there. My x is to the power of 5, and then the over 2 means to put it in a square root. So it's going to be like this, x to the 5 power and under a square root. minus. My 10x is to the 3 power, and the half puts it back under a square root. Now, for my last term, 1/2 is a square root, but if it's negative, where does it belong? Push it down to the bottom. So it'll be plus 3 over the square root of x. Just like that. We feel like we can do that? Okay. Go ahead and turn the page for me. We're going to do one more like that with cubic roots. Okay. One more like that with cubic roots. Okay, number 11. Now, before you start on number 11, will you change the first 5 to an 8? Okay, otherwise you have 2 x's to the 5. All right, so I want you to rewrite it, take the derivative, and then put it back in square root form, see how you do. Okay, remember that a cubic root is going to be over 3 instead of over 2. Okay? And you can look up and check your rewrite before you start taking the derivative. Like $4. So if you're in the negatives, the number will be kind of the same one. Okay, so let's do 8 times 30 cents. Or sorry, 8 times 6. Or if you do 45 by 3, you still get 6. So it's really whichever way you see that. So that's 6 by 3. 2 and 2 times it, okay? Okay, don't forget to switch it back to square roots when you're done. Okay, let's see how we're doing. So this should be labeled y equals still. And then when we get to the derivative, we're going to change it to y prime or dy dx. Okay, same thing. Okay, for your first derivative, It's 6 divided by 3 is 2 times 8 is a 16. And then when I minus, I'm going to minus 3/3. What's 8/3 minus 3/3? X to the 5/3. Okay, next term. I want 5/3 times 9. Well, I'm going to do 9 divided by 3. What's that? 3 times the leftover 5 is 15. Then I'm going to minus 3/3. What's 5/3 take away 3/3? X to the 2/3. Okay, last one. What's 1/3 of 12? That'd be 4. Okay, or if you want to do it the way that we were doing it, what's 12 divided by 3? It's 4. Times it by the leftover 1, it stays at 4. Okay, then when I minus 3/3, what's 1/3 take away 3/3? Negative 2/3. Then I need to switch it back into radical form. So it's going to be y prime equals 16x to the 5. And then the third gives me a cubic root. Okay, for my next term, it's a 15x squared. And then under a cubic root. For my plus 4, because this one has a negative on it, remember that's going to sink it into the denominator. So it'll be over an x2 under a cubic root. Okay, overall, how we doing? Good? Okay. We're going to skip the tricky ones, and I want you to go to just the very last page. Okay, there are 4 special rules that are pretty easy to use. So we're just going to go over those first so that you can do more of your homework right off the bat. So go to this last page right here. Okay, the derivative of sine is going to be cosine x. And then the derivative of cosine is going to go to negative sine x. Now, what ends up happening is you get into this weird cycle, right? That sine goes to cosine, and then what does cosine go back to? Negative sine. So I want you to write to the side, snow cone, snow cone. Bottom 2 are negative. Okay, when you take a derivative, you're just going to go through that list. So here's what I mean. Sine, the derivative goes to cosine. Derivative of that goes to negative sine. Negative sine goes to negative cosine, and then you go back to the top. So you're just going to cycle through them because it's a pattern. Okay? E to the x is its own derivative. Okay, that's the only function that's the case for. And then ln x is going to turn into a 1 over x. For now, don't worry about memorizing them. You have them all on your sheet. Let's do number 17. I have 4x squared plus cosine x plus e to the x minus 7. We're taking the derivative. What's the derivative of 4x squared? So 2 times 4 is 8. X is now just regular, no power on. Okay, then I get to a cosine. I'm going to use my snow cone, snow cone. If I'm on cosine, that's here, and I go down 1, what does that put me at? Negative sine x. Okay, then I get to my e to the x, and e to the x is special because it doesn't change even when you take the derivative. So I'm going to keep a plus e to the x. Then what happens to my minus 7? Minus 7 is a constant, so it goes to 0. That's your answer. Okay, now let's take the second derivative. I have an 8x. What's the derivative of that? Just an 8, because my x was to the 1. So 1 times 8 is 8. X drops to the 0. Okay, now I'm on negative sine, and I need to go down 1. Where does that put me at? Negative cosine. And then e to the x is special, because when you take the derivative, what happens? Stays the same. Very good. Okay, last one. I want the derivative of 8 in the front. What's the derivative of just an 8? 0, because 0 is a what? Constant. Then I want the derivative of negative cosine. That's the bottom of the list. Where do I go from the bottom of the list? Back up to the top, I'm at positive sine. What's the derivative of e to the x? Still e to the x. Get it? All right, let's do number 18. Last one before you have some time to work. Okay, I have an equation. We're taking the first derivative. What is 5 times 3? 15x to the what? To the 4. Very good. Plus. Then I have a 4 ln x, and ln x is special. What's the derivative of ln x? 1 over x. So I'm going to have 4 times 1 over x. Okay, the 4 is there because it was already in the front, right? Okay, and then what about the plus 9? 9's a constant, goes to 0. Okay, from here, before I take the derivative again, okay, 4 times 1, I'm just going to make that one fraction instead of, I'm just going to make it 4 over x. Okay, there's no point in keeping a 4 and a times 1 like in separate pieces. Okay, now I want to take the derivative again. Is there anything I'm going to have to rewrite that's not written as a power right now? The x on the bottom, we can't leave it there. How do we pull an x up to the top? What do we use? Negative. So I'm just going to rewrite that one part, and I'm going to put RW. This is really 4x to the minus 1. Okay, why do I want it in that form? So that I can do the power rule on. So let's take the derivative. Here we go. 4 times 15, what's that? 60x to the what? To the 3. And now when I get to 4 over x, I'm going to call that 4x to the negative 1. So that what's negative 1 times 4? Negative 4. And then I'm going to take away one more from the power. What's my new power? Negative 2. Okay. Then we're going to take the derivative one more time before we rewrite it. What is 3 times 60? 180x to the what? Squared. And then what's negative 2 times negative 4? Positive 8x to the what? If it was already a negative 2 and I'm minusing one more. Negative 3. Then for your homework, if you type this in, it specifically says no negative exponents. So you just need to take that x to the minus 3 and turn it into a fraction. So this one will go to 60x3 4 over x squared. Then it'll count it right. And then this one is going to go to 180x squared plus 8 over x3. Okay. And for the majority of the AP test, it's the same rule, that they're not going to leave your exponents with negatives. Okay, you get it? All right, pull out your delta math. You can do everything, but not the level 3s. Don't do any level 3s. Okay? No level 3s. Everything else you can do. Here you go. Okay, then the delta math code, since a lot of y'all aren't in mine yet, is right here. Yes? Oh, yeah. Okay, if you'll just go ahead and join that, that would be great. We wait till the bathroom passes back in the issue. Well, oh, there you are. Are you ready to take it now?
Here.
Almost here. What do you prefer? Okay. And then you can use our calculator for that part. Make sure if it says use the definition of quantity, you want to make sure that you're following the 3 steps.
Most of them.
Okay. You want to sit at that back table right there with the little sorts? Or if you want to sit on the floor in the hallway, that's fine. Or if you want to sit at your desk. Does anyone need this code up here longer? Okay. Okay, do number 1 and then try number 2. Number 2 is kind of a trick. So I'm gonna pull it up in a second. Everybody logged in? Can I take it off? So you still need it? That's okay.
Like, I love this project, like, oh. Oh, wait.
This is for, yeah. This is just for the homework. I do need to put the classroom code up, but not. Okay, are we good then? This is like the normal, if you've already been with me, you already have it. Okay, so look at today's homework. And if you haven't already done number 1, just go to number 2. Okay, a lot of people in my other class were confused about this. Okay, it asks you to take the derivative of pi squared. Okay, what type of number is pi? 3.14 is what type of number? It's a constant. What's the derivative of a constant? 0. If there's not an x in the equation, it's a constant. So what if they give you e squared? What would the derivative of that still be? 0. If there's not an x in the equation, your derivative is 0. Okay, so just don't get tricked by that. No level 3s right now. Okay, and if you want scratch paper, I have some. You want a little scratch paper? Here we go. You want that? Yeah. How many papers do you want? Okay, the first one should be pretty easy. Paper over here. Need your paper back here? And cheap for the bathroom. Thank you for waiting. Okay. Yeah. The x goes to itself. Is there an x in it? Then it's a constant. Does that make sense? Like, make sure you're using like calculus. So for this one, you're gonna want to take the derivative, and then if there's an x left, you'll put it. Okay, so let's go up to some of the easier ones first, where you don't have to. So what is that? Yes.
That's it.
What would that mean? And then your x is gonna go down a power, so it's square, so it's gonna be right. Okay, let's get the x out. I ate it because around that high. Everybody. Yes. I've always been on this. Thank you. And then x to the left. Oh, backwards. And you can use the keyboard has the square in it, or you can do shift 6. But either one. And then we just learned about, you can probably do learn that. So you can probably do at least the beginning part of your homework. Oh, that should be a 14, yeah. Uh-huh. Uh-huh, and then the 5 drops off. Good job. Oh, yeah. Didn't you have a question? Uh-huh. Okay, so e to the x stays the same. What is that? E to the what? Uh-huh, and where's the x? It doesn't have one, right? So then that means it's a constant. What's the derivative of a constant? Mm-hmm. Yeah. Uh-huh. Could be a minus one, yep. Yes? Your answers are to -2. I think your front numbers are wrong. For sure. So it should have been, oh, okay, this is 4/3. X to the -2. How did you make that a 4 plus 3? So what is that? See how it's a 4/3, and then you pull the x up, so now what's? Oh, okay, yeah, totally got it. So now -2 times 4/3 is gonna be -8/3. And then your -2 will go to negative, and then you'll have to drop back down to the bottom, because no negative exponent. Yeah. Yeah. Yes, sir. What's the derivative of x? It's got a number in it. It'll be 1. And then if there's no x, you don't have any more. So just. Okay, y'all, when you get to this section where it says to evaluate, it says derivative function evaluation, you're gonna take the derivative and then just plug that number in, okay? Now, this entire section, that's what you're doing. Now, you will eventually get a question like this. Okay, you don't have this exact same question, but what is the derivative of this? -5 period, right? There's no x left. Then the answer is -5. Here's why that happens. This is a line. Remember y equals mx plus b? What's the slope of the whole line, no matter where you are? -5. So if the derivative comes out to just be a number, I don't have anywhere to plug this x in, but that's because for a straight line, your slope is the same no matter where you are on the line. So if the derivative doesn't have an x left, you can disregard what you're supposed to plug in, just pick that number. Okay? Yeah. Or which one? You just forgot the 3 in the front. So remember the 3 comes down and then it goes to the next square. What's the derivative of 3x? So it's 3x to the 1. That's okay, just take the derivative of this one. So 3x to the 1. So it's 1 times 3. Then take off the x, it's just 3, right? There's nowhere for me to plug this in, then you're going to plug this in. You see what I'm saying? Yeah, so my question is different. But basically, if you take the derivative and you don't have an x to plug the number in, it's okay.
I know you want to like that's. I don't know what she's. I really didn't.
Okay? Okay. Yes. That's just. You're not plugging in a number. Okay? Yes? Okay, what's the derivative? Okay, so write down on your scratch paper, this is 5x to the 1 minus 4. And then take the root. So we're gonna do 1 times 5 is, and then x drops down to the what? 0, so it goes away, and then what's the derivative of minus 4? Because it's a constant, that's right. Then you see what I'm saying? No, it's the same. So for my question that's up there, my answer would have been minus 5. Because I never ever have to plug in the x equals -2. Because if you think about, remember, we're finding slopes, right? So if I were to graph that, it's a straight line. The slope's always the same. Like for you, your slope is always 5. It doesn't matter if I'm at 2, 10, 100. So if it's a linear function and you take the derivative, you just get a number. That's the answer no matter what x is. Okay? So negative x and 30. What is negative 8 times 3? Oh. Oh, remember the minus 4 is gone because you took the derivative.
Oh.
So your constant's gonna drop off, so that's what it should be. Uh-huh. I love to help. No problem. And then plug that. That's right. Yes? You did negative, okay, remember the 5 has to go to the front though. So it'd be negative 5x. Remember how you're always like timesing that number down to the front? Oh, so just sneak a 5 in there, and then you have minus 36x, 3 minus that. Now it's perfect. No, wait, hold on, not there. You want to put it here. Oh, yeah. Oh, and then put your negative sign.
Negative in front of the 5?
Uh-huh. So it should be negative, so 5 times
one.
-1 is a negative 5,
Okay.
and then blah, blah, blah.
Okay, thank you.
Good?
Mhm.
Leo, how we doing? Leo, you doing? Nini, how we doing? Ooh, good job. Doing okay? Do you need my docent? You have it already? Okay. You're talking about the video? Usually I just email it to whoever. So since you're here, we just. Question? You'll let me know one for each.
Actually, I have to put it on my laptop.
And then yours.
Oh my God, I was having a laugh and help. I was on
And that's a negative cosine. So that becomes opposite. So +2. Keep the 2. Yes. Yeah, give me one. Yes.
I think this one was super.
But this.
Then bring back the one that you can. That's true. Just cause you still,
makes sense.
for
You
a
plug
different
in
thing, you're like,
zero.
okay, so we're gonna take the calculators away. I don't think. I love when I get this.
I love that, Michelle, too. I love it when you get them right. No, no, what a negative spin to put on that. Minus 37. Just like you did. Okay, actually, you have to want to issue. This is right. If you brought this, yeah, your 3, and then the 2 pairs, but if you're bringing it up from the bottom, you remember this needs to be a negative 2 thirds. So now this is gonna be a negative 2, and what's negative 2 thirds minus 3? Do you see what I'm saying? But you had the right idea. If you're really bad. Y'all, if you get your review back and it's not 100, you can finish it and return it. From today's? Yes.
Bye. I sat there and read my
No more X. Remember, so.
You want to you have to find new stuff.
It should just be a +5 period, no X still on that. Yes? Go ahead, say it. Say you need me, I'm right here. Aaliyah, you just had 1 reset, right? Cause your other one is in a set of 8 or a set of 5, so it'll just give you a new one. And then you had some homework you did after the due date. Will you email me to take like no? Okay, yes. So let's rewrite it. So make it 4/3 is your number. And then if your X squared is coming up from the bottom. Okay, so now let's do our derivative. So what's -2 times 4/3? Just times the top. What's -2 times 4? -8/3. And since it can't divide by 3, we'll just leave it 3 on the bottom. Now I need to minus 1 more from -2. There we go. Now when you write your answer, it says no negative exponents. So you're going to take your x to the -3 and you're going to put it back down on the bottom of the bracket. So it'll be -8/3x. And once you push it into the bottom, it doesn't have the negative. You can do those. Those have like E and LN. 6 times 4 is not 20. Silly girl. Silly girl. There we go. 20. Okay, everything else is right.
Why did I think it was 20? I think I was thinking of 5 times. No.
You know, who knows? Who knows what you did? It's okay.
Anyway.
It happens to the best of us, okay? It's no problem.
She's not gonna let that go.
I will let it go, okay? Natalie. All right, Natalie, you're reset.
Bye.
You know what time the right state is on?
That doesn't, I keep telling you, I don't know what it is.
Yes.
She's saying the game.
Yeah.
I'm really brain so out. What percent are you on? I'm just
I didn't know it was on there. Y'all, when you get to, there's one that says derivative of tan. We need to just, I don't know why it's not on your notes. Let's add it real quick. The derivative of tan is secant squared. Okay, so let's just squeeze that in here. D dx tan x is secant squared x. Okay, just add one more rule to that. Okay, we're gonna do two more examples very quickly. So if you're on one right now, go ahead and finish it. That way you can do your level 3s. Okay, that'll only happen though in the specials at the very end. Okay. Are we ready to do our last two? No. Well, sadly. We gotta do them. So go to number 13, please. Number 13. Okay, this is gonna be a level 3. So if you wanna label it. Okay, and you only have a couple of these. 90% of your homework you should be able to do right now. Okay, so first thing I want you to rewrite this. So I have a 4 root x. How can I rewrite that? Four x to the 1/2. Okay, then minus my 8 is over a square root x. So can I put x to the 1/2 again? What's wrong with that? It needs to be negative because it came from the bottom. So now it's a negative 1/2 up top. Good? Okay, remember, this is just me setting up to take the power rule. So this is still f. Okay, f prime, here we go. We're taking the derivative. So 1/2 of 4 is what in the front? 2. And then I'm going to minus 2/2 from 1/2. What's 1/2 minus 2/2? Negative 1/2 is correct. Very good. Next term, I have minus 1/2 of minus 8. What's 1/2 of 8? And it's a plus 4 because I did a minus times another minus, they cross out. Okay, then what is x to the negative 1/2 minus 2 more halves? Negative 3 halves. Very good. Now, remember, we don't want to leave any negatives up top. So we're going to pull those down to the bottom. So this final derivative is going to be 2 over. And then if it's x to the minus 1/2, that's really a square root x on the bottom. Good so far? Okay, next term. I have a plus 4. My x is going to go on the bottom. And then remember, the top number is the power. The bottom number is the root. So this is a power of 3 and then under a square root. Now, this will give me the slope for any x that I want. But what x is it asking me to plug in? F prime of 3. So let's do that now. F prime of 3 equals 2 over root 3 plus 4 over root 3 cubed. Okay, do we know what 3 cubed is? What number is that? Okay, so 3 times 3 is 9, times 1 more is 27. That's correct. So I want you to write over here to the side, just that one term. I have the square root of 27. Okay, the reason I put this in tricky is that you have to remember how to take the perfect square out of that. So 27 is the same as 9 times 3. But the reason I would want to split these up is because the square root of 9 is perfect. What's the square root of 9? Regular 3. So now I can write this as 3 root 3 on the bottom. So here's what we have so far. 2 over root 3 plus 4 over 3 root 3. Everybody good to there? A little ugly, but hopefully we can do it. Okay, then the instructions on Delta Math say to write your answer as one single fraction. And the problem with that is how many fractions do we have added? 2. So all that we have to do to get it into one fraction is get a common denominator. They both have a root 3, but what does this one need? A 3 in the front. So if I put a 3 on the bottom, I have to times a 3 on top, which means what's that number on the top now? 6. Okay, so I have 6 plus 4 on top. What is 6 plus 4? 10 over 3 root 3. Okay. So you kind of go about it the same way, but then you just have to do a little bit of like geometry on the square root. Okay, last one we're going to do together today. If you will turn the page, please, to number 16. Okay, number 16. Okay, go ahead and rewrite your equation. So RW stands for rewrite. Any x's to the half are going to become x's to the, or any square roots are going to become x's to the half. So I have 1x to the half plus 4x to the half. Is that right? Okay, multiple things wrong with it. Tell me one. Okay, the 4 is not allowed to do this. Okay, the 4 is a 1/4. That is correct. Thank you. Okay, there's one other problem. The first one, where did the square root come from? Came from the bottom, then it's a -1/2 up top. So the correct rewrite, so it doesn't look ugly, is 1x to the -1/2 plus a 4th x to the 1/2. Okay, that's my correct rewrite. Now let's take the derivative. What is -1/2 times just a 1 in the front? -1/2. Then I want to minus 1 from the power, so I'm going to minus it 2 halves. So I have -1/2 minus 2 more halves. -3 halves. Very good. Okay, next term, I want 1/2 of a 4th. Remember, times the tops times the bottoms. What's 1 times 1? 1. What's 2 times 4? 1/8. And then I have a 1/2 minus a 2 halves. How many is that going to be? Minus 2 halves would be -1/2. Okay, now let's take our roots, push them back into the bottom. So I'm going to have -1/2. And then if I'm sending this x into the bottom, it's just going to join the 2 and just make it like one big fraction. So it'll be 2 square root x cubed. Same thing with the second one. I have a 1/8, but then my x to the -1/2 is just going to join the 8 on the bottom. Okay, then I'm being kind of lazy. I'm going to go back and label. This was still f, but this is now f prime. And this is f prime at any x that I want, but I want a specific x. What x do I want this time? F prime of 4. Okay, and the nice thing about 4 is that I can square root 4. So let's do it. F prime of 4 is -1/2 square root 4 cubed plus 1/8 square root 4. What is the square root of 4? 2. And what is 2 cubed? 2 times 2 is 4 times 2 is 8. And then times 1 more 2 in front of that. 16. So I have -1/16 plus, what's the square root of 4 here? 2 times 8, another 16. And if they already have a common denominator, you can just add them together. You only have to like make them the same if they're not. So what is -1/16 plus 1/16? 0. Okay, that would have been a horizontal slope if it asked you, would you? Okay, do you get the idea? If the level 3s are stressing you out, save them for next time. Okay, you have a few more minutes. Try to get a few more of the rest of the homework done. Okay, but don't stress on the level 3s. Yes. Sure. We just take the back and pass it. Thanks. That's gonna be a 1x to the. Oh, wait, hold on. You took that first. Yeah, so you'll keep a +1 there, and now you're gonna just take the -2 and plug it into your equation. So what's -2 squared? Times 6 is 4, and then plus 1 more. Yes? Uh-huh. You did 3x to the negative, that's right. Okay, so let's times this by that. So what's -2 times 3? And now divide it. Huh? So it's gonna be a -2 in the front, and now I have a -2/3, and I want a -3/3. Because remember, you always wanna do like one whole fraction. So it's -2/3 minus 3/3. Okay, x to the -5/3, and then to type in your answer, you'll have to take the x to the 5/3, bring it to the bottom, so it'll be -2 over. And then x is gonna be to the power of 5. And under cube. And then you have the cube root button. Yes. Yeah, you'll just keep the cube button. But if it's a negative cosine, you're already at the bottom of the snow cone, so you go up to the top and be a +2. So, does that make sense? Yes. Uh-huh. That would be your negative exponent, so I look at this one. Okay, but here, I'll help you. So write it down, you have 4/3x squared, and we can only bring the x up, so 4/3 is stuff. So it'll be 4/3 x to the minus. Okay, then we're taking the derivative, so if you -2 times 4/3, what would that be? So you do -2 times 4. And then if you divide by 3, do it just again. So it'd be -8/3. And then x to the what? Huh? And then you have to send this back down to the bottom. So it'll be a -8 over 3x, and it'll just kind of join down. Now it's not negative anymore. Oh, once you push it into the bottom, that means it'll go away. Yes? That's right. Uh-huh. So you're gonna just circle this term and bring it down like this. So it'll be a -8 over. Hold on, it's not over 2. Hold on, so it'd be -8/3. And then your x. We're only gonna have one this two like. Does that make sense? Yeah. So you have, like, okay, your super. So when you change your x to a 2/3, see how it's on the bottom? So it needs to be a -2/3. You pull it up to the top. So now here's why that matters. What's -2 times? Okay. Okay, now also, if it's a -2/3, minus 3/3. Uh-huh.
So then there's the negatives.
So it should be an x to the +5/3. Yes, that's right. Good job.
That's just really.
Yes.
What was that?
Earlier.
Okay, have you taken the derivative yet? You did -6x squared plus 6x, that's perfect, then plug in it 2. What's, I need to do the exponent first, what's 2 squared? Times 6. -24.
Oh.
How to do that?
I don't know. We're not doing it, I just added. Yeah, when I show you everything, that's I just added. Like, you see how we use it, right?
So it'd be -24 plus 12.
Yeah.
Because you take the difference and they keep the bigger signs. Yes?
Okay, Yeah. I think we should ask you to split both. The first thing to do, next it's either or if you want to finish and turn it back.
Oh. Yeah.
I'm gonna put your review on your desk, okay? You just put it back where it was, kind of behind that little bit. Daniel, your review is right here, okay?
But actually, yeah, when I give you the title. Yeah, we can play that. You know what? I'm gonna like to ask. And then she. No, I didn't. No,